All right, so let's get going on today's class. So what we're going to do today is we're going to start a extended look at a very important idea for this class for experimental methods in psychology, and that is the idea of complex experimental designs. So far we have only taken a look at the basic experimental design, the post-test only, pre-test, post-test designs. And while that basic design is very helpful answering some questions, there's other questions that psychologists want to ask that cannot be assessed with those particular designs. So we get into the slightly more complex designs that we're going to focus on today. So we're going to take a look at designs that will help us answer questions such as if you have a treatment, if you have a treatment that you're designing and it might work for depression, people with depression, and it might work with people with OCD. So it's a new drug, a new pharmacological treatment, and you want to test whether it works on either one of those disorders. You cannot use the simple designs that we looked at before. You would need to use a more complicated, complex experimental design. And we'll take a look at research that has actually been carried out on different learning styles and the ability to learn information. And I've often seen teachers create information or learning materials such as this. So we have here a poem about mighty mammals, about the whales. Whales are enormous, their size is tremendous, their length is fantastic, their weight is stupendous. So the question is are these learning tools actually effective? And specifically, do they match up with the way that learning is assessed? So again, we'll take a look at that psychology question and see how we need more complicated versions of the experimental design in order to answer those important questions. And we'll also take a look at another example that took a look at sexual behavior, specifically predatory behavior, or more specifically, the perception of sexual interest. So far in the Me Too movement, I believe there has been one high-profile case that has actually made it completed to trial, and that is Bill Cosby's case. But typically when you were hearing about issues with the Me Too movement or incidences in the Me Too movement, it was always very powerful males. So it was people like Harvey Weinstein, it was people like Kevin Spacey who were being accused, it was individuals like Bill Cosby, and people started to wonder, well, is this just some sort of toxic masculinity type situation that we have here? Is that why so much of this sexual aggression is occurring? And then interesting things started happening where women started to be accused. So Asia Argento was allegedly raped a child. There's no other way to put it. She allegedly raped a 17-year-old boy, and he came out and accused her, and people started to think, well, maybe it's not just males. Maybe it's not just a toxic masculinity. Maybe it is quite possible for women as well to be sexual predators. So a study looked at the perception of sexual interest and whether or not that's affected by the gender of the individual that is judging that interest. So we'll take a look at that as well. And again, it's a topic that cannot be assessed with the sort of simple pre-test, post-test designs we've encountered so far. And then lastly, probably not today, we'll take a look at a multi-level complex experimental design that wanted to take a look at the halo effect. And what it did is it set up a mock scholarship simulation where it asked subjects to make decisions on which application would deserve a scholarship. And what they did was they included images of the hypothetical people that were submitting these applications, and they wanted to know what effect does attractiveness have on your perceived scholarship merit. So if you are an attractive male, is that going to be beneficial for you? Will people look at your scholarship application and say, oh yes, I would rather give it to this individual than this individual? Or will it actually work against you? Will they actually take a look at this person and say, well, he's too gorgeous to be intelligent. Of course, I'm not going to give him a scholarship. And is that effect the same for when people are determining female candidates? And does that effect change when it's males judging male candidates, males judging female candidates, females judging male candidates, and female judging female candidates? So it's a very interesting study that takes a look at this idea of the halo effect, this idea of attractiveness affecting people's judgments. And it could not have been done, again, in that simple pre-test, post-test experimental design that we've encountered so far. So that's the kind of general goal. That's what we're going to be looking at. Real psychology questions that used complex designs to answer those interesting questions. So we'll start off with a look at factorial designs. This is actually, as an example, we'll take a look at our study, which is a factorial design. We'll importantly take a look at how do you interpret a factorial design. So we'll take a look at main effects and interactions. Some of this will sound familiar because we just wrote up the results section. That's almost kind of like your pretest for this. Main effects and interactions, now we're ready to understand exactly what it was that was going on. Interactions are especially important, especially in psychology, where our behavior is determined by a number of different factors, which oftentimes come together and amplify each other in weird and wacky ways. So we'll take a look at the importance of those, and then we'll dive in and take a look at some of those examples from psychology research on learning styles, on perceptions of sexual interest, on the halo effect, and just sort of see how this has been applied to answer those questions. So power and biases in sexual interest, attractiveness and perceived academic merit as well. All right, so factorial designs. So a factorial design is used when you design an experiment that has more than one independent variable. So up until now, we've only discussed experiments that have one variable. So for example, in our pre-test, post-test experimental designs, it was TV violence. That was the only thing we were interested in. Does TV violence cause aggressive behavior? But sometimes you want to ask about more than just one variable. So for example, you might, if you're an educational psychologist, want to know what is the effect of tutoring hours and study hours on grades. Not just what's the effect of tutoring hours on grades, or what's the effect of study hours on grades, but what's the effect of both of those together. And importantly, this is the only way that you are going to be able to see if there's an interaction between those two variables. Does tutoring hours magnify or amplify the effect of study hours, for example? That can only be assessed when you have those two variables. You might ask yourself, well, what is the effect of watching sad movies and listening to sad music on depression for men and for women? So these are typical types of questions that psychologists will ask. And the general format for these in a factorial design is that you report or you identify these as the number of levels that you have for your first independent variable multiplied by the number of levels that you have for your second independent variable, multiplied by the number of variables that you have for your third level, multiplied by however many levels you have, however many independent variables you have. So that's the general format when you're reporting a factorial design. So let's take a look at these simple examples first. So let's say that you were doing a study on the effect of tutoring hours and study hours on grades. And for tutoring, you had 3 levels. Half of your subjects. 1/3 of your subjects received 0 tutoring hours. 1/3 of your subjects received 1 hour of tutoring. 1/3 of your subjects received 2 hours of tutoring. That's one variable with 3 levels. You have a second variable, which is the amount of studying that they do. 1/2 of your subjects do 0 hours of studying. The other half of your subjects do 1 hour of studying. So let's say that that's the design of the experiment. This design here would be summarized here by saying that we have a 1, 2, 3 levels of tutoring by 1, 2 levels of studying factorial design. And this multiplication here basically is a way of summarizing how many different conditions are in this one experiment. So we got 3 tutoring conditions, we got 2 studying conditions, and a factorial design uses every combination of your conditions to form the entire set of unique conditions. And in this case, we got 3 times 2, we got 6 unique conditions. So we have students that received 0 hours of tutoring and 0 hours of studying. Students that received 0 hours of tutoring and 1 hour of studying. Students that received 1 hour of tutoring and 0 hours of studying. 1 hour of tutoring, 1 hour of studying, 2 hours of tutoring, 0 hours of studying, and then finally 2 hours of tutoring and 1 hour of studying. 6 unique combinations, 3 by 2 factorial design. The other example we suggested here, what is the effect of watching sad movies and listening to sad music on depression for men and for women? In this case, we got 3 variables. We want to know what is the effect of movies, sad versus control. So half of the subjects are shown a sad movie, half of the subjects are shown a control movie. What is the effect of music, sad music or control music? Half of the subjects listen to sad music, half of the subjects listen to a control song. And then what is the effect of gender, male or female? Half of the subjects, let's say, are male, half of the subjects are female. In this case, we have a 2 by 2 by 2 factorial design. So we got 2 levels of movies by 2 levels of music by 2 levels of gender factorial design. So in this case, we have 8 unique combinations. We have males that listen to sad music and watch sad movies. We have males that listen to sad music and watch a control movie. We have males that listen to control music and watch a sad movie. We have males that listen to control music and watch a control movie. We have females that listen to sad music, watch sad movies. Females, sad music, control movies. Females, control music, sad movies. And then finally, females, control music, control movies. 8 unique combinations. And that's very, very quickly communicated by using this format of saying, oh, I have a 2 by 2 by 2 factorial design. So if somebody came up to me and said, oh, I'm designing an experiment, and my experiment is going to be a 2 by 2 by 2 factorial design, I might not know what their experiment's about. I might have no idea what it is that they're investigating, but I immediately know that they have 1, 2, 3 independent variables. They got 2 levels in each. They got 8 unique combinations. So a lot of information can be communicated in that one little phrase. All right, any questions so far on factorial designs? All right. So you can have, in a factorial design, one way to envision it is it's just a continuous multiplication of every single condition that you've had. It's almost like you add another dimension to your experiment every single time you add another variable. So let's say that you have 1 independent variable, and your independent variable has 4 different levels. Right? So let's say that you're studying ages. It's a developmental study. So you have young children, young adults, older adults. You have 4 different levels. You have 4 groups of subjects. That's for a single independent variable experiment. As soon as you add a second variable, as soon as you say, all right, well, I'm studying memory of young children, young adults, older adults, and not only do I want to study memory for words, but I also want to study memory for pictures as well. What you need to do is you need to take every single one of your original conditions and then you multiply it by the second level of your second independent variable. So whereas in this experiment, this group would learn a list of words, learn a list of words, learn a list of words, learn a list of words. You take those same groups and you say, all right, I'm going to multiply it now, but by pictures. So young children, learn a list of words. Young children, learn a list of pictures. Older children, words. Older children, pictures. Young adults, words. Young adults, pictures. Old adults, words. Old adults, pictures. And that gives you now 8 conditions. We've multiplied it by that second dimension. And then you might say, well, I'm also interested in the third variable, time of day. Is your memory better at different times of day? And I'm going to study all of these conditions in the morning, and I'm going to study them in the afternoon, and I'm going to study them in the evening. And now we have 24 unique combinations. So you can see that you always, it can get very complex very quickly, where you can have, we add one more level, we can go up to 80 unique combinations. So usually 3 variables is sort of the limit at which your brain can really wrap its mind around these. But theoretically, there's no reason why you can't have 4, 5, 6, 7 independent variables in your study. All right, so just to kind of give you one last example of this, our study that we did on false memories and group size, that was at Factorial Design. We had one independent variable that had 3 levels, that was group type. We had a second independent variable that had 2 levels, that was item type. Was it a correct item or was it a false memory critical item? So we had 6 unique combinations in a 2x3 Factorial Design. I got a ladybug on top.
I thought you said a ladybug. It sounds like a what?
No, it's a ladybug, also known as a ladybird beetle. If you guys, do it that way. Okay, so we have this Factorial Design. One of the great benefits of a Factorial Design is that it gives you a lot of freedom in terms of what it is that you want to look at. Because once you have a Factorial Design, you can look at the effects of each variable by itself, and you can also look at how each variable interacts with the other variables. So we'll start off with the simpler one, which is the variables by themselves. That's a main effect. So the main effect is each variable on its own. And if we were to ask in this configuration here, what is the main effect of item type? So you remember when we were writing up the results section, we would say, oh, is there evidence of a main effect of item type? That is there evidence that item type on its own affects our memory? Is there evidence that we are better or worse at recalling true memories versus false memories? That's what the main effect of item type means. What it actually boils down to in essence is saying, you know what, we've done this experiment here, but we are not interested in group levels anymore. We're taking all of our data, and instead of having individuals, pairs, and triples, we're just going to say we got subjects. We got subjects remembering false items. We got subjects remembering correct items. So how did subjects versus subjects do? Not individuals, pairs, and groups of 3, but just how did the subjects do? Is there a difference between correct items and critical items? And as we saw, yes, indeed, there was a difference in percent recall between correct items and critical items. There was a main effect, and that's what this graph is indicating. This graph is collapsing all the data. So individuals, pairs, and triples are in here. Individuals, pairs, and triples are in here. And what this data is telling us is that, yes, all by itself, correct items were recalled more than critical items. All right, in the same way, you can find the effect of the second variable all by itself. So was there a main effect of group type? Did group size do anything on its own? And that's as if you said to yourself, all right, well, I tested singles, individuals, in groups of 3, and I tested them for false memories, and I tested them for correct memories, but I'm no longer interested in the false versus correct difference there. So let's get rid of that difference. All I'm interested in is how much did individuals remember, how much did pairs remember, how much did triples remember, and that's what we have here. So this is the main effect for group size. And as you recall when we were writing it up, there was no main effect of group size, indicating that the amount of words recalled, the percent recall for each group on its own was in fact the same. So there was no main effect, no effect of group size. However, that, and this is one of the reasons we do factorial designs, that doesn't mean that group size wasn't doing anything. Group size actually was doing something, but that only came out in the interaction. So interactions are where the effect of one independent variable, what one independent variable does, depends upon what the other independent variable is doing. So the effect of one independent variable is dependent upon what is the level of the other independent variable. And the easiest way I find for people to conceptualize or remember the idea of interactions in an experiment is to think about an interaction that we're probably all familiar with, an interaction that we've probably all been warned off of, and that is the interaction between prescription drugs and alcohol. So when you get prescribed prescription medication, usually one of the things that it says is do not take that prescription medication with alcohol. And the reason for that is because of drug interactions. And what a drug interaction is, it is the effect of this prescription drug will change depending upon whether or not you've ingested alcohol. So let's say that you're taking a prescription drug, and let's say that let's say that it's a painkiller. You've just had surgery. Your doctor has prescribed painkillers. Don't take the painkillers, you're going to be in pain. Take the painkillers, pain goes away. That's the effect of painkillers on their own. When you combine that with alcohol, it changes the effects of the painkillers. So without alcohol, take a painkiller, pain goes away. With alcohol, take a painkiller, you go to the hospital. You're destroying your liver, you need to get your stomach pumped. Different effect depending upon the level of the alcohol consumption. That's a drug interaction. What this drug does is dependent upon how much alcohol you have in your system, and that's why you're told, do not take this medication with alcohol. It's to avoid that interaction. So again, the prescription drug has one effect when you have zero alcohol in your system. The effect of the drug changes when you have more alcohol in your system. The effect of the drug interacts with the alcohol. So that's what we're looking for when we're talking about interactions. Does the variable do one thing in one situation and then do something completely different in another situation? So in our study here, we found an interaction of group type and item type. What that means is that the effect of group size for correct items was different than the effect of group size for incorrect items. So if somebody came up to you, another way to think about this is that if somebody came up to you and said, hey, I heard you did this experiment, what's the effect of group type? How does group size change memory? You would have to say, oh, it depends. It interacts. Are you talking about correct memories? Or are you talking about false memories? Because the story is different for correct versus false memories. The effect of group size interacts with the type of memory. So as we saw, for correct items, for the blue bars here, the larger your group, the better your memory. So memory improves, percent recall goes up as group size increases for correct items. But item type interacts with group size so that for critical items, there is no difference in percent recall as group size increases. So what's the effect of group size? It's just like asking, well, what's the effect of this prescription drug? It depends. If you have 0 alcohol in your system, it's a painkiller. If you have more than 0% alcohol in your system, it could be a potential life killer, depending upon how much you have. The effect changes. That's what an interaction is. And the only way to find these interactions, which are oftentimes the most interesting parts of an experiment, is to have these two variables in your experiment. That's the only way that you can get to that potential interaction, is by having those two variables to see if the story is different for one level versus another of those variables. All right, any questions on interaction so far? Cool. All right, so let's take a look at a little bit more conceptual ideas or details about interactions. We'll keep it kind of basic. Let's suppose that you have two variables. You have variable A and you have variable B, and they each have two levels. You have one dependent variable that you're measuring, and you have two independent variables. What are the possible outcomes of this hypothetical experiment? So as it turns out, there's 8 possible outcomes. So the first one, or the first two, come from the fact that your variable A could do something or might not do anything, right? It could do something or it could do nothing. So there's 2 outcomes. Either it does something or it does nothing. 2 possible outcomes for your first variable. For your second variable, there's 2 possible outcomes. Either your second variable does something or your second variable does nothing. And then finally, you have your 2 variable interaction. Either your 2 variables interact, so the level of one changes the effect of the other, or your 2 variables don't interact. They're independent. They act independently of each other. There's no interaction. And the kind of kicker to this, and the reason why it's so important to understand interactions, is that any combination of this is possible. Any combination of these 3 outcomes can be achieved or can occur in psychology. So it's very important to be able to interpret an interaction correctly, because if you just focus on the main effects, if that's all that you can that you understand, you're oftentimes going to miss the very important part of the story. So let's put these up visually here. We're not going to spend too much time on this part here, because this is where there's no interactions. So you can see here, just in terms of just setting this up, this is a graph of the effects. This is the 2 levels of variable A. These are the lines of the 2 levels of variable B. And here it says whether A has a main effect. So in this case it's no. Does B have a main effect? In this case it's no. Is there an interaction? In this case it's no. So these are the ones where either B has an effect or A has an effect, or they both do. But all of these are the no interaction cases. So we are not going to spend time on that. We're going to take a look at when there is an interaction. So in each of these cases, there is an interaction. In each of these cases, the effect of A is different for the different levels of B. But importantly, that can occur when, for example, B looks like it's doing nothing. It can occur when A looks like it's doing nothing. And it can occur when A and B both look like they're doing nothing. So it's quite possible that your main effects say, no, this variable does nothing, but your interaction says, oh yes, it does. It's just only coming out in the interaction. And that's why it's vitally important to understand how interactions work, because otherwise you might be missing a crucial portion of the outcome. So this is a little difficult sometimes to grasp hypothetically. So let's put a situation on top of this so we can anchor our thoughts. We'll go back to that clinical treatment of depression and OCD. So let's say that you work in a clinic that treats people with depression, and you work in that same clinic and it also treats people with OCD, obsessive compulsive disorder, and you develop a new technique, a pharmacological drug that you're hoping will cure depression and or obsessive compulsive disorder. So what you would do is you would have the type of disorder, depression versus OCD. That's one of your independent variables. Either you have depression or you have OCD. Your other variable is their level of function before the treatment and then after the treatment. So you have them before they take the drug, you have them after they take the drug. Before or after is your second independent variable. So we have that here, where we got before the treatment, after the drug treatment. And then here we have a scale of mental functioning. And this would be a sort of generalized test of mental functioning that you could give to any disorder to measure how are they functioning in general. And basically higher scores indicate better functioning. You want your drug to give them higher scores. All right, so we have pre versus post. That is the A variable. We got mental functioning. That is B. So we have pre versus post. A, yes, there's a main effect. We're going to see that mental functioning is better in post. B, on the other hand, says that there's no main effect. What this means is that in general, there was no difference between the functioning of the OCD individuals and the functioning of the depression individuals. There's no difference there. If you don't understand the interaction, you might say to yourself, great, my drug works, and great, there's no difference between depression and OCD. It's a drug for both of them. It's a cure for both individuals. This interaction says, no, it's not a cure for both. And you only get that when you understand the interaction. So what's going on here? Well, this is the outcome of what occurred. So in this case, your OCD patients, they started off with really low mental functioning before the drug. After the drug, their mental functioning skyrocketed, right? It went from 1 to 9. Your depression individuals, they started with a medium level of mental functioning, and your drug did nothing. It did nothing for these individuals. So when you're taking a look at this interaction, and you're asking yourself first, was there an effect of the drug on its own? Was there a main effect for the drug? What you're asking is, in general, was the functioning before the drug lower than the functioning after the drug? And if you take a look at the average level of functioning before and the average level of functioning after, yeah, it's higher after. So in general, people were better off after taking the drug. In general, there's a main effect for the drug. So that's the main effect for the drug right there for OCD and depression. If you then take a look at B over here and you say, oh great, there's no difference between OCD and depression levels of mental functioning, you would be tempted to say, yeah, this is for both of them. I have a drug now that's great for both. Where did this come from? It came from the fact that it came from the fact that the average level of depression across the entire experiment, we're not talking pre or post anymore, the average level of depression is 5. Your average level of OCD is the average of 9 and 1, that's also 5. So on average, your depressed individuals and your OC individuals have no difference on their in this experiment. So that doesn't mean that your drug works for both, because it comes out in the interaction. And the interaction is saying, yes, you got a wonder drug for OCD, you have nothing for depression. It does absolutely nothing for depression. So if you only understood the main effects, you would erroneously say, oh, I got a drug that works for both. Great, that's perfect. Once you understand the interaction, you can see that, well, no, this is great. I got a drug for OCD. I'm going back to the drawing board for depression. Give you another example of why it's very important to understand interactions, why it's very important to have factorial designs where you can take a look at interactions. So let's take a look at this one here. Take a look at the main effect on its own. No main effect for pre versus post. So they were no better off. Your subjects were no better off after taking the drug than they were before taking the drug. Well, that's horrible. Was there a difference in mental functioning between the two disorders? No, there wasn't. So not only was there no difference between the two disorders in how they were functioning, but there was no difference in how they were functioning before and how they were functioning after getting the drug. In this case, you would probably say to yourself, again, if you don't understand interactions, you would say, well, my drug is doing nothing, and there's no difference between the two disorders, so back to the drawing board. Let's, that's it, we're done. I was really hoping for this treatment to be a new treatment, maybe to help people, but it looks like we're back to the drawing board. We'll throw it all in the trash, right? So you wouldn't do that, but anyways, that would be a mistake, because here there's an interaction. And what that means is that the true story, the real story, comes out in the interaction. And this is oftentimes seen in what's known as a crossover interaction. So how did we get no effect for pre versus post? Well, if you take a look at performance before the drug, some of your subjects were scoring 1, some of your subjects were scoring 9. Average of that is 5. What happened after the drug? Some of your subjects are scoring 9, some of your subjects are scoring 1. That's an average of 5. So there was no change in general pre to post. There was no change in mental functioning from before or after. And then if you take a look at, well, what about obsessive compulsive disorder individuals across the entire experiment? Well, they scored a 9 and they scored a 1. So on average, they had a mental functioning of 5. What about depression subjects across the experiment? They scored a 9, they scored a 1. So on average, they also had a score of 5. So there was no difference between the scores for the two groups of subjects. So this is what the result looks like when you take a look at the main effects. This is back to the drawing board. This is a waste of years and time, and you've got a treatment that does nothing. This is half a miracle drug and half a important insight into what is going on. So this is the interaction. That comes out here. This is saying that regardless of the fact that you have no main effects, the story of how your drug affects OCD is different from how your drug affects depression. The treatment interacts with the type of drug to give you these different effects. And what you have here is you have two wonderful things. Number one, you got a miracle cure for OCD. You got something that'll take them from a functioning of 1 all the way up to a functioning of 9. That is a super cure for OCD. Not only that, but you basically have depression poison, right? You basically have something that you can give people that will increase their depression. That gives you a clue as to the cause of depression, because whatever your drug is doing, whatever brain area it's affecting or hormone it's releasing or bodily change that it's making, that is what is causing depression. That is what's making depression worse. So you found poison for depression, which means that you're that much closer to finding a cure for depression. And again, none of that would come out by just looking at the main effects. It's very important to understand those interactions. All right, any questions on that hypothetical version? Everything making sense so far? All right, let's take a look at some actual psychology data. So once again, in educational psychology, there is a large myth that people are trying to fight in terms of preferred learning style. So a lot of students, a lot of educators, they kind of believe that preferred learning style, students learn better in their preferred learning style. In actuality, they don't. There's no evidence for that. Most of us are visual learners, whether we prefer that style or not. But it doesn't stop people from trying different learning approaches. So they oftentimes, like I said, try different things, such as using rhyming to help people learn information. So once again, these mighty mammals seem to think they can fly. They leap from the water into blue sky, as if they are birds and their flippers are wings and they are bouncing on some hidden springs. So this has been used, for example, to teach students about whales. The question is it effective? Does it actually work? And that's where a psychology experiment would come in. So this was a study done by Morris, Bransford, and Franks back in 1977. And they want to know if learning style does the best learning style depend upon the testing or the real life situation in which you're going to use the information? So in terms of learning style, is it best to match the learning style with the testing situation, or does it not matter? Is there some other effect that occurs? So what they did is they had two independent variables, independent variable A and independent variable B. And in independent variable A, that was the encoding condition. How did you learn the information? What style was the information presented to you? Independent variable B, that was a type of recognition test. How were you tested on the information? What was the style of the testing? So encoding condition, independent variable A, the encoding condition, had two levels. Independent variable B also had two levels, the recognition type. So we have a 2x2 factorial design. What they did is they presented pairs of words to individuals. And they actually, no, sorry, another experiment I was thinking of. They presented a word to individuals, and you were in two different encoding conditions. Half of the subjects were asked to think of a word that rhymes with the word that they just saw. So you would see a list of words, just like you saw a list of words in our experiment. And for each word, they asked you to think of a word that rhymes with that word. So if you saw chair, you might say hair. If you saw frog, you might say log. If you saw car, you might say, superstar, whatever it is. You had to think of a word that rhymed with the word. That was how you encoded your information. That was half of the subject. The other half of the subjects had to encode this semantically. And what they did was they asked them for each word, what we want you to do is decide, is it alive or is it not alive? Is it an animate or inanimate object? So if you saw a chair, you would read it and say, that's not alive. You saw a frog, that's alive. You saw car, not alive. So you had to make a decision that was a semantic decision that required you to access information about the meaning of the word. So to figure out if a word, or to figure out a new word that rhymes with the word, you don't need to know what that actual word is. So if I say something like bajananon, right? Do you guys know what a bajananon is? No, you don't. Do you know what a phenomenon is? Do the two of them rhyme? You can say that even if you don't know what a bajananon is. And now I got to come up with that because I just made it up. Anyways, you might not know what bajananon is, but you can come up with a rhyme. If I asked you bajananon, living or non-living, you have no idea. So it's accessing two different types of information. Semantic is typically thought of as a deeper type of processing. What they did then is they had them learn in these two types of situations. They then had them do a recognition type test with two different types of recognition. So what they asked them is they presented them with words, and they asked them, did you see a word previously here that rhymes with the word you're looking at right now? Okay, so if you previously saw chair, they might put a word up that says underwear and say, have you seen this word before? That's a word that rhymes with this word in your previous list. That was the rhyming recognition type. And then the other one was a standard recognition type. Have you seen this word, right? You looked at chair, here's chair on the page. You simply say yes or no, I've seen it before. You've seen frog, here's frog on a page. You simply say yes or no, I've seen it before. So not words that rhymed with what you saw, but words that were actually the ones that you saw, your standard kind of recognition test type. All right, any questions on that, the general design? All right, let's get to what they found. So, what we have here is on the y-axis here, we got proportion correctly recognized. Basically, the higher the bar, the better your performance, right? So this would be 90% correct, 20% correct down here. And again, you just have to circle the words that you've seen before and not circle the words that you had not seen before, or circle the words that rhyme with words you've seen before or not. Encoding condition here, we got people that encoded the information as a rhyme, people that encoded the information semantically, alive or dead, people that encoded it as a rhyme, people that encoded it as semantic. And then over here, we have the performance of individuals on the standard recognition test. And here we have performance of the individuals on the rhyme recognition test. And that gives us our 4 different conditions. So we had people that learned it with a rhyme, were tested with a rhyme. People that learned it with a rhyme were tested with a standard test, learned it semantically, tested it with a rhyme, learned it semantically, tested it with a standard test. We got 4 different conditions. How did they do? Well, for the standard recognition test, for people that learned it semantically, their performance was very, very high. For people in a standard recognition test that learned it via rhyme, their performance was much lower. So not surprisingly, the reason that most of you, when you're trying to learn, when you're trying to study material, you're not sitting there going complex experimental design rhymes with firmplex developmental recline. Oh yeah, that's going to help me. You kind of know this already, right? Rhyming is not going to be that good. But what about if you learned it as a rhyme? What if you encoded it as a rhyme and then you were tested in a rhyming situation? Well, in that case, semantic individuals, people that learned it semantically but then were tested in a rhyming situation, they did rather poorly. And people that learned it in a rhyming condition and then were tested in a rhyming condition actually did better in that situation. So these are the overall results that they have. And now we're going to take a look and we're going to break those down and we're going to see, were there main effects, were there interactions, and what exactly is the story coming out of this data here. All right, so first off, main effect of A. Is there a better way to encode? So is one way of encoding superior to the other way of encoding? Is there a difference in proportional correct between semantic encoding and rhyme encoding? Bless you. So what we want to know is that in general, regardless of how you're tested, is it better to encode in one way or is it better to encode in another way? So who here wants to tackle that? Is there a main effect in general across this experiment? Ignoring the way that people were tested, is it better for subjects to have encoded in one way, or is it better for them to have encoded in another way? Or is there almost no difference? All right, I'll get the ball rolling on this one. Okay, so not as simple and straightforward sometimes as one might imagine. When you're asking that, and you're looking at an interaction here, right? When you're asking it and you're looking at a graph like this, what you need to do is you need to kind of collapse across conditions. So what we can do is we can say, all right, let's take a look at everybody that encoded semantically. On average, how did the people that encoded semantically do? So we have people that encoded semantically and were tested in a standard test. We got people that were encoded semantically and were tested in a rhyming test. So on average, people that encoded semantically did about that good, right? They got about just under 60% correct in their recall. So this is the average I encoded it semantically performance. For the rhyme performance, this is how rhymers did when they encoded it in a rhyming way on a standard test. This is how rhymers did when they were tested in a rhyming condition. And you take the average of that, and surprisingly, just a little bit lower. So on average, people that used a rhyming scheme performed just a little bit lower than people who encoded the information semantically. So this main effect would probably mislead you into thinking, you know what, you want to learn this information semantically? Learn it semantically. You want to learn it via a rhyme? Look, it's almost as good. You know, so if you prefer to learn via rhymes, learn via rhymes. It's almost as good as learning semantically. So if you want to go home and say, yeah, complex experimental design, suplex developmental resign, great, that's fine. You're still going to be doing just about as good as semantics. That's what the main effect of encoding condition says. As you can imagine, that's not the real story. But there is a main effect of encoding condition, slightly better for semantic, but not that much compared to the rhyming condition. What about the main effect? Whoops. Yeah. So yes, there is what I basically just said. Yes, semantic encoding is better, but just barely. All right, what about a main effect of B? Is there a better way to actually test? Were people superior in their recognition scores for one way of testing, the rhyming way of testing, versus the standard semantic way of testing? So this one is a little bit more visually apparent. So anybody want to let me know which way of testing produced higher recognition scores? Mm-hmm. The standard did, exactly. So it didn't matter if you encoded via rhyming or if you encoded via semantic. If you take a look at the average performance on the standard recognition test, that's the average performance right there. So we have, again, that's how the semantic encoders did on the standard recognition test. That's how the rhyming encoders did on the standard recognition test. That's how subjects on average did on the standard recognition test. You take a look at the rhyme recognition test. That's how rhyming encoders did on the rhyme recognition test. That's how semantic encoders did on the rhyme recognition test. That's how subjects on average did on the rhyme recognition test. And you can see that there is a big difference here. You do way better on standard recognition tests than you do on rhyme recognition tests. So what this effect is telling us is that you will perform better on a standard recognition test than you will on a rhyme recognition test, regardless of how you've actually encoded. In general, standard recognition is better than rhyme recognition. And that's why typically in a school here, when you're doing multiple choice tests, they will say, which one of these options do you recognize? Which one of these options, is the correct definition of an independent variable, and not which one of these options rhymes with the correct definition of an independent variable. Because a rhyming test is just going to produce far, far poorer results. And if you have a professor that does rhyming tests, if you have a professor that says something like, why don't you write me a poem about independent variables, probably you're going to have a harder time than you will for somebody who's like, why don't you write me an essay about independent variables? All right, so that's the main effect of the type of testing. Was there an interaction? Was there an interaction between the two? That is the best learning style dependent upon how you're actually being tested? Is there a difference between the effects of a coding and coding conditions? Is it dependent upon the effects of how you're being tested? And for this one, this is where you have to take a look at all 4 bars. You have to take a look at what is the story in each section of this experiment. So for standard recognition tests, rhyming is poorer than semantic encoding. So if you're doing standard recognition tests, you are worse off if you learn using rhyming than you are if you learn using semantic encoding. But that doesn't mean that semantic is always better. Because if you are doing a rhyme recognition test, you are better off learning under rhyming encoding than you are learning under semantic encoding. So what this means is if a friend of yours comes up to you and says, you know what, you're a psychologist, I'm struggling in my course, how should I study? Should I study trying to learn the material by rhyming it? Or should I study trying to learn the material by semantic understanding? According to this research, your answer will be, it depends. What kind of tests is your professor giving you? And if they say, oh, our professor is this weird professor, they really like using rhyming tests, well, then you would say, oh, that puts you in this story. In that case, yeah, definitely learn the material by rhyming. That's going to be better off for you in that course. If, on the other hand, they said, yeah, my professor's standard type of test, semantic understanding, then you would say, oh, well, now the story changes. Now you're in this section here where semantic encoding is what you actually need to do. So what's the best type of encoding? It interacts with how are you being tested. If you're being tested in a rhyming condition, learn it under rhyming encoding. If you're being tested in a semantic condition, best to learn it under semantic encoding. And that's one of the reasons why semantic encoding is typically preferred. Semantic tests are typically used because in the real world, people usually want to know, do you understand this? So in the real world, somebody will come up to you if you're a psychologist and say, you know what, I have a client and they're battling depression. Do you understand things about depression? Do you have semantic knowledge about things about depression? And you would say, yes, I do. Depression works like this, it works like this, it works like this. Nobody in the real world is ever going to say, oh, I have a client, they're suffering from depression. You're a psychologist. Can you bust me off some sweet rhymes about depression? And you'd be like, oh yeah, well, my name is depression and I'm here to say. Nobody's going to ever ask you to do that. So in general, because we're in a world that tests us, that makes us access our knowledge in standard recognition forms, it's way better to learn information in a semantic way. So as fun as these songs and poems might be, they're actually not as effective as learning that information in a more straightforward semantic way, because learning it by rhyming is not going to help you unless you're being tested also by rhyming. All right, any questions on that? All right. So we're probably not going to have time to go through the entire experiment on sexual interest and perceived sexual interest. So what I'm going to do is I'm going to set it up, and then next time we come back, we'll try to see what people kind of guessed is going to be the answer for this. So research like this has become increasingly important because it was recently made very aware that there is issues with sexual predation, with sexual assault, with people in power taking advantage of people that are not in power. And it was a very interesting kind of dynamic to see where when it first came out, it was male perpetrator after male perpetrator after male perpetrator. And then eventually it was discovered that females committed acts of assault as well. So with the whole sort of push towards gender equality, with more women getting positions of power, it became very important to know, how do we tackle this, this issue of sexual assault, this issue of sexual harassment? Is it a gender issue, right? Is it because of things like toxic masculinity? If so, then the way that we get around it is by dealing with those particular factors, those toxic masculinity factors. Is it not a gender issue? Is it a power issue? If that's the case, then you have to deal with the factors that do with power. So we want to get rid of sexual harassment. Do we attack it because it's gender that's causing this? Or do we attack it via power structures? That's what this study was going to took a look at. So this is a very recent study. This is by Kunzman and Maynor back in 2011. And what they did is they had a staged manipulation, and they had participants who were told that they were going to work with a partner on a task that simulated making decisions in an organization, right? So they were basically told it's going to be like, you guys are on the board of directors, and you're going to have to decide, about what happens in this company. So they were told again that they would work with a partner on that task. The actual experiment, though, was about biases in sexual interest. They actually wanted to know what affects how interested you perceive somebody else to be in you. And I'll mention that again because there's a lot of things going around, right? So sexual interest is kind of multi-layered. And when you see somebody pass by, you can be attracted to them. That's sexual interest. They might pass you by and you might say, I always try to say this in like as straightforward a way as possible. And I always sound like some robot that I just learned how to feel. They walk by and you're like, boy, they have piqued my sexual interest. I would be open to pursuing a sexual relationship with that person, right? So there's that form of physical attraction. But there's also perceived sexual interest. And that's when you look at the person and say, all right, I might want to have sexual activities with them, and I am perceiving that they are also interested in me. Or I am perceiving that they are in no way interested in me whatsoever. That's also perceptions of sexual interest. So that's what they were looking at. They were looking at, for these subjects, when they make a decision about this person that they just looked at, how interested is that person in pursuing a sexual relationship with the subject themselves? That's what they were looking at in terms of perception. So what they would do is, prior to interacting with this individual, they watched a 2-minute video of their opposite sex partner, right? So this was designed for heterosexuals. They would watch a video of an opposite sex partner, and partner is in quotes there because it wasn't a real subject. This was a staged video where they were pre-recorded, and they would just say things like, well, you know, this is the person that you're going to be working with. Why don't you take a look at this 2-minute video that we took earlier today? So they would watch this 2-minute video of their opposite sex partner, and then they would answer questions about the partner's sexual interest. Things like, how likely do you think this person would want to go out with you on a date? How likely do you think this person would find you attractive? Indicators of that other person's sexual interest. So the participants in this study, the ones watching the video, they were either male or female. So we had males watching females on the 2-minute video. We had females watching males on a 2-minute video as well. So that was the first variable, male versus female. And the second variable was that these subjects were placed into either a power situation or they were placed into an equality situation. And the way that they did this was that this experiment was for course credit. And a person in an equal position was told, you and this other individual, let's make this easy. There's 10 course points, 10 points of course credit for participating in this experiment. And you and the person in the video are going to get 5 each. So 5 is going to go to you for participating in this experiment, 5 is going to go to the other person. That's the equal position. Subjects that were placed into the power position were told, you're going to watch this video of your partner in this experiment. Oh, and by the way, you're going to be the one that decides who gets credits by the end of it. So there's 10 credits in total, and you are going to decide how many credits your partner gets. So you can say, you know what, I'm going to take 5, and you take 5. Or you can say, you know what, I'm going to take 8, and I'm just going to give you 2. Or I'm going to take 10, and you're going to walk out of here with nothing. So they were placed in a power position. They had authority over this individual here. So we take a look at the breakdown. We have subject sex and we have subject power condition. So we had males that were watching a female partner on a videotape. We had females that were watching a male partner on a videotape. And the males were told that they were either a leader, in which case they decided how the points got split up, or they were told that they were equals, so that they both got equal points. And then females were told, half of them were told that they were leaders. They decided how many points they get and how many points their male partners get, or that they were equals. They got 5 and their partners got 5. So we got 4 conditions here. We got males and females, males and females, males in the power condition, males given the leadership position, males given the equality position, females given the leadership position, females given the equality position. And then what happened is, after watching the video, after being told that you were a leader or being told that you were equals, you then watched the video. And after you watched the video, they asked you questions about the partner's romantic interest. So you just watched this video, And then they asked you questions about how much would this person be interested in pursuing you as a sexual mating choice? How interested would that person be in pursuing you as a potential partner? So they would ask things like, I could see this person having romantic or sexual feelings for me, right? On a scale of 1 to 10. How true is this statement? They would ask him, I could see this person wanting to ask me out on a date. So they, again, and this is the big thing to keep clear in your minds. This is about, what do you think the other person thinks about you? How do you perceive their perceived interest? And one of the things that is especially important in understanding this is that this is where sexual harassment occurs. So sexual assault would need another experiment, because sexual assault has a clear line. There's a clear legal, this is where you do not go, line for sexual assault. Sexual harassment is a little bit more in that gray area, and it depends upon a lot of reading of certain cues. So when you see somebody that walks by, oftentimes you might think to yourself, you know what? I'm going to pay that person a compliment. That is quite a nice jacket that that person has. And you have to decide, are they going to take that compliment in a good way? Or are they not going to take that compliment in a good way? So I've actually had this occur to me. You guys might remember the flowery jacket that I had a couple of weeks ago. Somebody actually came up to me and said, wow, that is a great flowery jacket. I have a bra that looks exactly like that. They followed that up with, I hope it's okay that I said that. And I told them, that's completely fine. I'm not offended. I'm not embarrassed or anything. But they were perceiving this is probably okay to make this compliment. And then they were like, oh, maybe it's not okay. So they had that perception of, is it okay or is it not okay? When you're asking somebody, for example, out on a date, when you're asking somebody, would you be interested in going out on a date with me? Would you be interested in this particular physical contact? Is it okay for me to go up and hug you, right? So a lot of sexual harassment is people complaining that their bosses are always asking them out on dates. People complaining that they've gone to a lunch work meeting and it turned into, drinks and will you go back to my place? People complaining that they're continually being complimented on their physical appearance, right? Basically, people complaining that they're being perceived as receptive to those advances, right? So it's a very small proportion of individuals that I think are standing there and they're saying, you know what? There goes that coworker of mine. And if I ask them out on a date, it's really going to piss them off. It's really going to make that coworker angry. And they made me angry. So off I go. Hey, do you want to go out this Friday? No? Ha, I got you. None of them are doing that, right? Very small proportion, I would imagine, of individuals are doing that. What they're doing, though, is they're taking a look at that individual and they're saying, you know what, my coworker there, something about the way they've been acting, I think they're kind of interested. I think they would, they kind of find me attractive. They would probably be receptive to me asking them out. They would probably, if I say, hey, you want to go out on Friday? They'd probably be sitting there going, oh my gosh, I can't wait. Can't believe it took you so long to ask me. That's a great idea. Let me ask them if they want to go out on Friday. And what's happening is that sexual harassment is occurring because people are misperceiving those rules. That's what they're measuring here. And what we're going to see is males that are leaders, do they misperceive this more than males who are equals? And does that affect change? Does that affect change for gender? So do leaders misperceive this more than equals do? Are you more likely to get asked out by your boss than you are by a coworker? And if your boss is a female or a male, does that change how likely they are to over-bias your interest in them? That's what we're going to be looking at next time. So what I'd like you to do, just like a thought experiment, try to figure out what happens in this experiment. Try to figure out, first off, for leaders and equals, do leaders perceive more sexual interest in their partners than equals do? Do males perceive, in general, more sexual interest in their partners than females do? And is the effect of leader versus equals different for males versus females? And we'll see that data next time we meet. All right, so that is it for today's class. So like I said, I will we'll take this up next time. Try to think about what those effects might be. Try to come up with your own guesses. And next time we meet, we'll see the results for this. And we'll also introduce the ideas for the perceived attractiveness study and whether or not you're better off getting a scholarship if you're very attractive or if you're unattractive, and if that matters, if you're a male or a female.